In this lesson, we're going to look at element compounds and mixtures. We're going to look at the definition of each and also some common examples. So firstly, elements. Elements are pure substances that cannot be broken down into two or more simpler substances by chemical methods or chemical processes or by any methods. So the key word here is that it cannot be broken down. So if I want to look up an element, the place that I need to go to would be your periodic table that looks something like this. Now in the periodic table there is a dividing line which looks like a staircase. Knowledge of this is not required for O levels, but all you need to know is to the left of the staircase, the elements found, they are actually metals, and the elements found on the right, they are non-metals. Now if we think of a common example of a metal and a non-metal, chances are many of y'all would tell me that an example of a metal would be iron. Okay, an example of a non-metal would be, for example, hydrogen or oxygen, or even argon or neon. Now what we're going to do next is that we're going to look at the arrangement of particles in a metal and a non-metal, and for that we need to use some of the knowledge that we have learned in kinetic particle theory. Now based on your daily life knowledge, iron at room temperature is actually a solid. So if we were to zoom into a sample of iron, you will find that the particles are closely packed in an orderly manner, something like this. Okay, so this is iron, or it is representative of any metals. For hydrogen, if you can recall, hydrogen is actually a gas. So if we were to zoom into a sample of hydrogen gas, we will find that the particles are very far apart, and it has no orderly arrangement. One thing that you may pick out over here is that when I draw hydrogen, I seem to draw two particles that are stuck together, or they are touching each other. Now why is that so is that we're going to learn later that one hydrogen atom on its own is not stable. Okay, so it would combine with another hydrogen atom to form what we call hydrogen gas, H2, and each unit that is formed is actually called a molecule. And since there are two atoms in each molecule, we call it a diatomic molecule. Now, so you may be asking now, how do I know which elements are diatomic? For that, you need to remember this. Again, we have learned this in your kinetic particle theory. Have no fear of ice cold beer. So these are the 7 elements that you need to know in the syllabus that exist as diatomic molecules. So lastly, we look at argon. Argon is in group 0. So we are also going to learn later the elements in group 0, they are stable enough to exist as single atoms. So in a sample of argon, which is also a gas, all you see would be this, that the atoms are far apart in a disorderly manner. Now for ease of comparison, later I am going to label these diagrams. For example, diagram A, diagram B, and diagram C, because later we will be comparing across diagrams, and if need be, you will need to rewind to an earlier part of the video to make a comparison. Now before we move to the next slide, I've mentioned just now that the staircase, the division line, is not really in syllabus. So in the context of our O levels, all we need to remember is this: the elements in groups 1, 2 and 3 they are metals. Okay, elements in other groups from group 4 all the way to group 0, they are non-metals. Okay, now we'll look at compounds. Compounds are also pure substances, but they contain two or more elements that are chemically combined in a fixed ratio. So the keyword here would be two or more elements that are chemically combined. So in the syllabus, we're going to learn two types of compounds. Right? First type is called ionic compound. The other type is called covalent compound. Why are there different types of compounds? It's because we can combine either a metal with a non-metal, or we can combine two non-metals. When we combine a metal with a non-metal, we get an ionic compound, and when we combine two non-metals, we actually get a covalent compound. So at this point, some of you all may be asking, how about combining metal and metal chemically? Now, we will learn in chemical bonding later that metals do not combine with metals. So in reality, we will not see a metal combining chemically with another metal. At most, we can mix the two metals together, which we will see in the next definition. So back to the two types of compounds, ionic and covalent. Same thing, I'm going to ask for an example of ionic compound, meaning something that has a metal combined with a non-metal, and a covalent compound. The typical examples that you will be able to think of would be your sodium chloride, which is your kitchen salt. Yeah, sodium chloride, sodium is a metal, chlorine is a non-metal, so when they combine together, it's an ionic compound. Examples of covalent compound, I think most of you all will be able to think about carbon dioxide. It's present in air and maybe water. So once again, let us take a look at how the particles are arranged, how they look like when we zoom into the substances. Now if you zoom into a sample of sodium chloride, okay, if you can imagine your kitchen salt is found in the solid state. So I'm going to draw the particles, again closely packed in an orderly manner. Okay, notice something different in this diagram. Okay, the thing that's different is that now there seems to be two types of particles, because one of the circle is unshaded, the other one is shaded. So that tells you that there are two types of particles present, meaning there are two elements that are combined together. So I'm going to label this diagram E, or diagram D. So at this point, it will be good for you to compare and contrast diagram D with diagram A earlier. Alright, and for that you will see that diagram A, all the circles are the same, and then for diagram D we have two different types of particles, therefore it must be a compound. Next, if we were to zoom into a sample of carbon dioxide has this formula CO2. So carbon dioxide is a gas, so we will see something like this. The particles are far apart in a disorderly manner, and if you can see over here, this is a molecule again, because there are three atoms that are chemically combined together. But what is different for diagram E versus diagram B just now for oxygen is that now you see that in each molecule there are two different particles that are combined together in each molecule. So this means that you have two or more elements that are chemically combined, so this is a compound. Lastly, I'm going to draw the diagram for water. Water has the formula H2O and it's a liquid. So once again it's closely packed. So water will look something like this. Now when we look at the diagram for water, again you notice that it is made up of molecules. All the molecules are the same, so it's a pure substance, but within each molecule it seems to be made out of two types of circles, one big and two small. Okay, so over here, as long as the particles either have a different color or have a different size, it means that it belongs to a different element. So over here, since within each molecule there are two different types of particles, we call this a compound as well. So let's call this diagram F. So we have seen that in a compound that the elements are chemically combined. So if they are chemically combined, means that there's a strong attraction between them. So it's not easy for us to separate the elements in a compound. So what we need to know is that they can only be broken down, they can only be separated using chemical methods. There are two chemical methods that we need to learn in the syllabus. One of them involves the use of heat to break down the compound, right? So for which we call it thermal decomposition. Decomposition is the breaking down of a large compound into smaller ones. And the second chemical method that we need to learn in the syllabus is by using electricity, or by applying a current, and we call that electrolysis. We're going to learn both methods later on in the year, or as we progress in chemistry. Lastly, for mixtures are made up of two or more substances that are not chemically combined. So they are only physically mixed. So take note that mixtures are impure, and you need to remember three very famous examples of mixtures. One is air. By now you should already know that air is a mixture of nitrogen, oxygen, and then there are some gases like carbon dioxide and argon. So they are simply mixed together. Nitrogen is not chemically combined to oxygen. It is not chemically combined to carbon dioxide. They are just mixed together. The next important example is that of alloy. What is an alloy? Alloy is a mixture of a metal with another element. Now the other element cannot be another metal, so that's when we have a metal mixed with another metal. So there are three alloys that we need to know in the syllabus, first of which is steel. This one is the most important. Next is brass, and third is bronze. So you need to know what are the elements present in steel, brass and bronze. Steel is a mixture of iron plus carbon. Brass is a mixture of copper plus zinc, and bronze is a mixture of copper plus tin. Sn is tin. And the last important example of a mixture is crude oil or petroleum. Now they are used interchangeably. Alright, so when I say crude oil, it means petroleum. When I say petroleum, it means crude oil. What are they? They are a mixture of hydrocarbons. Okay, we're going to learn this in the one of the last few topics in chemistry, and I'm going to just tell you slight in advance what is a hydrocarbon. As the name suggests, hydro means hydrogen, carbon means carbon. So hydrocarbon would be compounds that contain carbon and hydrogen only. Alright, so we need to remember these three famous examples of mixtures. Now, how then do we draw representations of mixtures? That's very, very easy. We have diagrams from A to F in the previous slides. So if you take any two diagrams and combine them together, you will actually get a mixture. For example, if we combine the two diagrams A plus C, so if we combine diagrams A plus C, this is what we'll get. Okay, I hope you can see from this diagram that this is no longer pure, alright, because we have two different elements or two different types of particles in there. Essentially, this represents an alloy. Okay, we can also combine B plus C. What would we get? We will get something like this. We will get something like this. Okay, once again, I hope that you can see that this is no longer pure. Why? Because we have two types of molecules or two types of substances that are not chemically combined. This one and this, they are different and they are not chemically combined. So this is a mixture. This would be a rough representation for air as well. So similarly, I can also combine B plus E. So I'll combine B plus E, and this is what I will get. So looking at the diagram here, I hope again you can see that this is not pure, this is a mixture, because this molecule is different from this molecule and they are not chemically combined. Now this is also like an example of air. In fact, air is a mixture of B, C and E all together, different gases that are mixed together. So we have seen that in a mixture the substances are not chemically combined, so there isn't a very strong attraction between them. We can separate them easily using physical methods. What are physical methods? We are going to look at all the different physical methods in the next chapter under purification and separation. For now, some examples would be like filtration, your distillation, crystallization. All this may sound familiar because you have learned them in lower sec. Now that we have looked at the definition of element compounds and mixtures and the common examples as well as how the particles appear at the particle level, let us now look at the three common types of questions that you will get in element compounds and mixtures. Now the first type of question is where they give you the name or formula of a substance and you're required to be able to tell us whether it's an element, compound or mixture. And there are some tricks that you can actually use to help you in classifying them. The first trick is as follows. If the name of a substance can be found in the periodic table, then it must be an element. For example, if you take a look, copper, can you find copper in the periodic table? Answer is yes. Can you find hydrogen in the periodic table? Answer is yes again. Alright, so from copper all the way to oxygen, you can find these names in the periodic table, meaning they are all elements. Any name that you can find in the periodic table is an element. The reverse is also true. Can I find carbon dioxide in the periodic table? Answer is no. So it is not an element. Can I find air in the periodic table? Answer is no again. So it's not an element. Now the next trick is this. If you can write a chemical formula for the substance, then it must be a compound. If you cannot write a chemical formula for the substance, then it must be a mixture. So for example, air, can we write a formula for air? Answer is no. Air is a mixture of formulas, so it must be a mixture. Ammonia, can we write a formula for ammonia? Answer is yes. Ammonia is NH3. Okay, so it's a compound. From the formula, I hope you can see that it has two different elements that are chemically combined together. Same for carbon dioxide, CO2, so it's a compound. Crude oil, we have learned this is a famous example of a mixture. Sodium chloride, NaCl, so it is a compound. Steel is an alloy, so it's a mixture. And then water has the formula H2O, so it's a compound. Now the second type of question is where they give you diagrams, and from the diagrams you are supposed to be able to tell us whether each diagram is an element, compound or mixture. So for that, bear in mind that for an element you only have one type of particles. For a compound, you have two or more different particles that are chemically combined, meaning they are touching one another. For a mixture, you would have two or more different molecules or two or more different types of particles that are not chemically combined. So for diagram A, I hope you can see that it's a compound. How do we know that it's compound? Because if we look at these two particles over here, they are of different sizes, and if two particles are of different sizes, it means that they are of different elements. So, and they are chemically combined because they are physically touching each other. Okay, so it is a compound. And if you look at the molecules in the diagram, they are all the same. So this is a pure substance, so this is a compound. For B, it is a mixture. Alright, how do I know that it's a mixture? Because there are two types of substances that are not physically, they are not chemically combined. So this is a mixture. Similarly, for C, there are two different types of substances that are not chemically combined. So it is a mixture as well. For D, it's a compound. How do I know that it's compound? Because if we look at each molecule, it's made up of three different types of circles. It's made up of three different elements, so it's compound. And each molecule, they are the same, so it's a pure substance. Element E is diagram E is an element. Why? Because all the particles are the same. Same for F is an element. G is a mixture once again, because there are two different types of molecules that are not chemically combined. H is an element, and then I is a compound. Now for mixtures, we can go on to ask you to further classify them, what kind of mixture that is. For example, for B, it's actually a mixture of elements, element plus element. For C, it's a mixture of element plus compound, because if we look at this is a compound, this is an element. And then for diagram G, is a mixture of compound plus compound. Now the last type of question that you will get is where we give you a description, and from the description you are supposed to deduce whether it's an element, compound or mixture based on what we know about element, compounds and mixtures. So for example, in the first description, when pure substance A was heated, a colorless gas and a white solid were obtained. So what is essentially describing here is that substance A had broken down into two simpler substances. Okay, so can it be an element? Answer is no. Alright, so in this case, the first one describes a compound. How do I know that it's a compound and not a mixture? Is because of the word pure over here. Compounds can be pure, mixtures are impure. Next, description. Substance B appears as a white solid in a colorless liquid. So now we have two substances in two different states. That means that they are not chemically combined, they are only mixed together. So this is definitely a mixture. And the last one, substance C cannot be broken down using heat or electricity. What does it mean? It means that it cannot be broken down by chemical processes, so it must be an element.